what we're going to work on today is really something that's not all that difficult. They're just calling it by a different name. And what that is a function. I've written up here, a function is a rule for using one number to calculate another number. When you were in probably second and third grade, they called it something different. They gave you a number and called it an input, and then on the other side of the box here, they would call the result the output. So we have one number, the input, that helps us calculate another number that we could call an output. So one number is the input. The second number is the output. Okay, and all together, that rule is a function. Okay, you'll deal a lot with functions when you get to calculus. Okay, so let's take a look at the one that they have for you there at the bottom of page 97. Okay, we know that to find the area of the side of a cube, we have to take length times width. Okay, and it comes out in in square centimeters. So if a cube has 2-inch sides, the area of one side would be 4. So if it has 3 centimeter edges, the side of one is 9, and so on and so forth. This would be a 4-inch cube. This would be a 5-inch cube. Now, if you recall, a cube has 6 faces. So if we want to figure out what's the area or the entire surface area of the entire cube, we would have to follow, we would figure that out by doing what? We would have, since there's 6 faces, we would have to take the area of one face times 6. So 4 times 6 is 24, 9 times 6 is 54, 16 times 6 is 96, and 25 times 6 is 150. This is an example of a function. It is a rule, and the rule is this times 6 gives us this. Okay, this is our input number, this is our output number, and therefore we have a function. Flip to the next page, please. Okay, first paragraph at the top says, your formula is an example of a function. A function is a rule for using one number, an input, to calculate another number, an output. In this function that I've drawn on the board, side area is the input and surface area is the output. Because the surface area of the cube depends on the area of each side, we say that the surface area of the cube is a function of the area of a side. We know that if we know the area of one side of a cube, we can apply the function to determine the entire surface area of the cube. I have a second rule, for example, 1 over here on the far side. Okay, here we have a box. The first input number is labeled L. That's an L, not a 1. L and M. So we're going to take input 5. What would we have to do to it to turn to 20? Now, I'm sure there are some of you who are going to go, oh, well, that's easy, Mrs. Needing, that's times 4. But if you apply that rule, times 4, 10 times 4 is not 25. 15 times 4 is not 30. So times 4 won't work. We have to come up with a different rule or a different function. Now, what could we do? 5, what can we do to 5 to get to 20? Well, we can't multiply, so let's try adding. What could we add to 5 to get to 20? That would be 15. Okay, let's try that one. 15 plus 5 is 20. 10 plus 15 is 25. And 15 plus 15 is 30. So now we know the rule or the function of that box. Okay? So to find M, we have to add 15 to L. All right? Now, I can very simply take off my M and label this L plus 15 equals M. Okay? That is my function, my rule for that side. Okay? Now, look at example 2. They take it a step further. I'm at the top of page 499. Okay? We have a box that says X. We have a box underneath it that says 3x minus 2. Now this table's arranged horizontally. The rule of the function is stated in the table. We multiply the value of x by 3 and then subtract 2. So we take the first one. 2 times 3 is 6. 6 minus 2 is 4. And that's what they have in the box under the number 2. The next value of x is 3. 3 times 3 is 9. Minus 2 is 7. And then on the last one, we take 4. 3, put it in the place of the x. 3 times 4 is 12. Minus 2 is 10. So the missing number is 10. Now, when you get to algebra in junior high, you're going to often be asked to graph functions. And many functions can be graphed on a coordinate plane. The one that they give you in the book shows a function table that relates the perimeter of a square to the length of one of its sides. So it says in the coordinate plane, we graph the number pairs that appear in the table. So if the side of one square is 1, its perimeter is 4. If the side of a square is 2, its perimeter is 8. If the side of a square is 3, then its perimeter would be 12. And if the side of the square is 4, then of course the perimeter would be 16. Then we turn those pairs of numbers into ordered pairs that we would graph. And so they have done that in the book. Okay, so we take the first ones, 1 and 4. So we go over 1 up to 4. And I think the next one is 2 and 8, 3 and 12, 4 and 16. Let's see if I can do this right. Right there. 20. Oh, that's as far as we go. But if you notice, we can draw a straight line then. Maybe. I don't know where well, we'll just eye it. Can't find my ruler. Right through there. Actually creates a straight line. So we could pick any number out here, let's say 6, and go up here, and we can predict 6 times 4 is 24. So that would be here on that line. Right? That is a graph of a function. All right. Look at example 3 on page 500. Okay, take a look at the problem. It says the perimeter of an equilateral triangle is a function of the length of its sides. Okay, there's a rule. Okay, make a table for this function using side lengths 1, 2, 3, 4. So you create a box, a table. You put the sides, S, 1 through 4, and then you figure out what P is. Well, the rule is 3 sides, so you multiply by 3. 1 times 3 is 3, 2 times 3 is 6, and so forth. And then they grafted it. Okay? And they used S as the first number in the ordered pair, and they used P as the second number. So 1 and 3, 2 and 6, 3 and 9, 4, 12. You could do 5 and 15, and you'd still be on that line. Okay? Now, I would encourage you, before you do assignment that you do the practice set, okay? And have somebody at home check it. And if you have any problems, make sure that you contact me, and I'll be happy to answer any of your questions. You can call me by phone. You can FaceTime me, whatever you need to do, okay? Let me know what you think of doing math this way, and we'll see if we're going to continue doing it, okay? Have a good evening or a good day. It's evening here. I'm doing this on Monday night. You're looking at this on Tuesday morning. I'll talk to you tomorrow at 10.